Today I want to talk about the deep circulation of the ocean. The ocean has like rivers in it, and we want to talk about what causes the rivers that are deep. There's shallow and deep. We kind of learned that in the last podcast, and today we want to figure out what causes the deep, not the shallow, the deep circulation of the ocean. So that's where we're headed today, so let's have at it. All right, so the deep circulation of the ocean. This is just an amazing graphic I was able to find. There are, underneath the water, there are all kinds of currents. For example, we have the Antarctic bottom water, and we'll talk more about that later. The circumpolar deep water, the North Atlantic deep water. This is kind of the north, and this is south, if you will. This is in terms of the latitudes. And let's talk about what causes all that. But before we do that, we want to talk about what an ocean current is. What's an ocean current? It's predominantly horizontal movement of ocean water. It's like a river of water that moves. Now, the pictures that we have here are the, not the pictures, but the diagrams and the arrows represent the currents. These are surface currents here from NOAA. So these are surface currents. We want to talk about what's happening deep underwater. And I've got an amazing little animation I will show you later. Now, what do ocean currents cause? So before we kind of dive into this, some important things I want you to understand. First of all, they carry matter. So they've got a river. So if you've got a river of water traveling underneath the ocean, it's going to carry stuff, matter, with it. It also carries energy, okay, because depending on the temperature, if it's hot, it's carrying warm energy, and you really can't say it's cold energy, but it's carrying energy because of the temperatures. And so a lot of the energy transport in the world, which causes lots of things, are huge. What does this affect? It carries the energy and matter. It affects various things. Important thing, it affects the climate. Okay, a classic example of this is that there is a warm current coming across near England or whatever, and it warms it up and makes it warmer than it ought to be because it's very far north. All right, the same is true of Norway and Sweden and such. It affects fishing because if it's carrying matter, some of that matter is food for the fish. Well, if you get a place where there's lots of extra food, it's going to make it good fishing grounds. A classic example of that is off the coast of Peru and Chile, is that there is some energy that, or it stirs up the ground and the bottom of the ocean, all the sediments, and then some of that sediments is edible. Not the actual sediments, but it creates a nutrient environment where lots of things can live. The fish feed on that, and it's an amazing place to go fishing. Energy transport, as we kind of alluded to, you can transport energy. A lot of the energy of the world gets moved around. Of course, some places of the world are hot and some are cold, but a lot of that is an effect of ocean currents. And another thing that's important, and we'll talk about this more in the next podcast, is transportation. If you are a ship captain and you're trying to get across the ocean, it'd be good to actually kind of get some extra gas, so to speak, if you could follow this current right here, and then you could save some energy. If you're trying to go from United States over to, say, Japan, that would be the way to go, but you wouldn't want to be a little further south where you'd be fighting that same problem. So it depends on where you want to go, okay? Now, the world is, here's a very important thing to understand, the world is unevenly heated. That means some parts of the world are heated more than others. Now you know that. The equator is warm and the poles are cold. Duh, right? Well, that means if there's more energy here, you're going to get some energy differences in the world. So when the sun's rays come to the earth, like on this diagram right here, it warms up the equator more, and it creates, this is in the air, atmosphere, it creates a convection cell. We've learned about convection cells before, where it rises and then falls, and it falls in the poles. Of course, we do have a particular problem. The world isn't always straight up and down. It is on March the 21st and September the 21st, but sometimes, it's tilted, and so it depends on who's tilted. So the tilt is part of the variable. Also, the fact that the Earth is rotating, that's another part of the variable. So it creates some interesting issues with winds. Turns out because of this, and we learned this in our last activity, that we get some curves of the wind. So in the northern hemisphere, things turn to the right. In the southern hemisphere, they turn to the left. And it creates different wind patterns, which then creates different temperature issues, which causes the currents of the ocean to be changed. All right? And so if we were, the second thing that also is true that's going to affect our currents is something called salinity. Now salinity comes from the word salt, right? Salinity is basically how much salt is in the water, or in more scientific terms, it's the concentration of dissolved salts in the seawater expressed in parts per thousand. Well, guess what? The salinity in the world is not consistent. Okay? Usually, they say that the salinity of the ocean is about 35 parts per thousand, actually, or grams per 1,000 grams of water. Okay, well, that's true where it's the green pictures, but on this map here, but it's not green everywhere. All right, you get higher concentrations, say here in the Mediterranean Sea and in the central part of the Atlantic Ocean, don't you? But you get very low concentrations of salt up in the polar regions. Shouldn't it be more? Actually, yeah, I'll say this. This is actually more of the yellow color. So you should have higher concentrations when it's in the lower latitudes, right? Yeah. Okay, so the salinity, and salinity plays a role. And you're going to do an activity where you're going to play with the salt to figure this out. So you're going to play with this and understand how this works. Yeah, here we can see the picture right here. Okay. All right, now let's talk some more on salinity. First of all, I've said this already, but we'll put it down. 35 grams per 1,000 grams of ocean water. That is the average. But the greater the salinity, the greater the density of water. So if there's more salt, that makes the water more dense. And as we've learned earlier in other podcasts and other class lessons, things that are more dense tend to sink. So if it's more dense, it will sink. So we can have water sinking in water. That's kind of a weird concept. But if you've got more dense water that has salt, it is saltier, then it will sink more. So the more dense the water, the higher the salinity. The higher the salinity. All right, so that's important to understand. The higher the salinity, the more dense the water. More dense water sinks. That's key to understand this whole process. All right. So what causes salinity variation? Means why is the ocean not a consistent saltiness or salinity? Well, one of the key things is large freshwater rivers. So if a freshwater river flows into the ocean, that doesn't have any salt in it, or very little, and therefore that, of course, dilutes the salt at the mouths of rivers. And the second thing, which of course is maybe the most important, is the freezing at the poles. So here we have an iceberg down here, and this iceberg, when it freezes, this is made of pure water. There is no salt. It is not salt water. This is salt water down here, right? Salzwasser. This salt water here is saltier because the icebergs freeze just the pure water. So this makes the Arctic water saltier, which makes it denser. It's also colder, and colder water is more dense. So we get kind of a combination. Oh, my thing is following me. Follow me. Okay, there we go. So here's kind of a temperature graph. All right, take a look at the temperature graph. And this is one that sort of is, you kind of go, oh, that makes sense. The warmest water, 30 degrees Celsius, would be closer to the poles. You kind of can see, or the equator, pardon me. This is the warmest water in the ocean, maybe off to here. And you can see where we have warm water, and then we've got very cold water, this purple color, down near the ocean. So what you've got at the poles is you have cold, salty water. So this is going to be the most dense water, right? And what you've got in at the equator, generally speaking, is you have warm and you have high density or low density water, and so it will tend to float. And that's one of the things that causes the ocean circulations.